Welcome to this explainer. You know that feeling, right? You're driving along, maybe a bit distracted, and suddenly, flash, you blow past a traffic camera and instantly check your speedometer, heart pounding. Well, for decades, that was basically the whole system. Just a basic, dumb camera waiting to snap a blurry photo of your license plate long after a rule was broken. But as our cities have grown and traffic has become vastly more complex, that old way just doesn't cut it anymore. We are in the middle of a massive shift. Those passive, old-school cameras are being replaced by highly intelligent, interconnected AI networks. We're talking about robotic traffic cops equipped with hyper-advanced sensors and deep learning. So today, we're going to unpack exactly how these digital detectives actually work.
Here's the roadmap for our tech detective journey today. First, we'll look at the shift from reactive to proactive systems, then map out the smart traffic ecosystem. After that, we'll see how they catch complex violations, explore the sheer power of data fusion, dive into predictive analytics, and finally wrap up with the challenges and what the future holds.
Section 1. From reactive to proactive, a new enforcement era. Okay, let's dive into this. As our urban populations absolutely explode, having actual humans manually monitor everything is practically obsolete. Traditional enforcement has always been incredibly reactive. You just sit around and wait to collect evidence after a crash has already happened. But AI enforcement completely changes the game. Modern systems are proactive. They continuously analyze live traffic streams to spot risky behavior right in real time. Instead of just handing out a ticket after the fact, transportation authorities can actually understand traffic behavior. They spot recurring patterns, which means they can improve overall road safety and stop accidents before they ever occur.
Section 2. The smart traffic ecosystem. Core components of AI.
To make this whole proactive vision a reality, these systems actually need to be able to see and understand their environment. And the absolute core of this is ANPR, or Automatic Number Plate Recognition. Now, these aren't just snapping simple photos. They use optical character recognition and heavy-duty deep learning algorithms to literally read license plates at highway speeds, in the pouring rain, or even through thick fog. Seriously, even if a driver thinks a thick layer of mud is going to hide their plate, the AI can usually still read it without missing a single beat. That recognized plate number becomes the primary anchor, a unique identifier that links every single detected event right back to a specific vehicle.
But here's the thing. Modern, intelligent traffic cameras do way more than just read plates. They use what's called edge AI, meaning the AI models are running right there inside the camera itself. Because of this, they can classify vehicle types, spot illegal turns, and, get this, even see right through your windshield to catch a seatbelt or mobile phone violation. They're tracking pedestrian movement and checking if motorcyclists are wearing helmets. And because the brain is on the edge, they save massive amounts of network bandwidth. They only send the data for these specific, meaningful events instead of just uploading a giant, heavy 24/7 video stream of nothing happening.
Vision alone isn't going to prevent accidents though, right? That is exactly where radar and LiDAR step in. Radar is amazing because it accurately measures a vehicle's speed completely independently of lighting or bad weather. Combine that radar with the plate readers and bam, you've got automated speed enforcement. But LiDAR takes it to a whole new level. It shoots out lasers to provide a highly precise 3D map of the environment. It evaluates how long a line of cars is waiting at a light, maps out exact vehicle trajectories, and runs immediate collision risk assessments. Put it all together, and these sensors give the system total three-dimensional spatial awareness.
Section 3. Catching complex traffic violations, AI-based detection.
So how do all these fancy sensors actually get deployed out there in the real world? Well, it's all about teamwork. Take speeding. The radar measures the speed, and the ANPR identifies the specific vehicle. For something trickier, like wrong-way driving, the AI has to analyze the full 3D vehicle trajectory by combining camera tracking with that LiDAR data we just talked about. And for those dangerous red light runners, the system integrates directly with the traffic signal controllers themselves. It syncs the exact status of the red light with the CCTV and visual evidence. This completely removes any ambiguity about whether that light was actually red when the car crossed the line.
Section 4. The power of data fusion, multi-device analytics.
And this brilliantly illustrates the real climax of our tech detectives process, correlating information from multiple totally independent devices. Think of it like a mini narrative of a traffic crime being solved in mere milliseconds. Step 1. The ANPR camera captures the license plate. Step 2. Simultaneously, the radar grabs the vehicle's speed. Step 3. The CCTV camera records the driver's actual behavior. Step 4. The traffic signal controller confirms the light was red. And finally, Step 5. The AI acts as the brain, combining all these separate observations to officially validate the violation. By fusing this data, the system creates a single, highly confident report, practically eliminating false positives.
The result? Every verified violation spits out a comprehensive digital evidence package. And this thing is bulletproof. We're talking high-res images, video clips, the exact plate recognition results, precise timestamps, GPS coordinates, the speed data, the signal status, and an overall AI confidence score. It creates a fully transparent, rock-solid package of evidence that confidently supports legal enforcement, leaving almost zero room for dispute.
Section 5. Predictive Analytics in Smart Cities. Smart City Integration.
By gathering mountains of historical violation data, these machine learning models can actually start to forecast future risks across an entire metropolis. It's wild. The AI can predict which specific intersections are most likely to experience speeding today. It forecasts when and where congestion will hit, identifies high-risk holidays, and pinpoints specific time windows that are super prone to accidents. By deeply understanding these seasonal and event-related traffic patterns, authorities stop just reacting. They deploy their resources proactively, putting officers right where they need to be before the accident even happens.
And all of this feeds into a unified operational picture. You see, these modern AI platforms don't just sit in a silo. They integrate seamlessly with police command centers, emergency responders, public transit grids, and even border control. It essentially creates a single, real-time pulse of the city's entire transportation network. Imagine the incredible coordination this allows during massive citywide events or major emergencies.
Section 6. Challenges and the future. What lies ahead?
Now, despite all these amazing advancements, we have to be real. There are some major hurdles to deploying this globally. Top of the list is privacy and data protection, given the massive volume of automated surveillance happening on our streets. Then there are the cybersecurity risks. If these interconnected systems get breached, it's a huge problem. We also have to actively manage AI model bias, deal with the incredibly high infrastructure costs of setting all this up, and face the absolute headache of integrating cutting-edge AI with clunky, decades-old legacy systems. Addressing all of this absolutely requires robust governance and rock-solid secure architectures.
But the innovation certainly isn't slowing down. Right now, we are pretty much mastering edge AI and predictive analytics. Looking to the near future, we're going to see vehicle-to-infrastructure communication, where your car literally talks directly to the smart intersection to keep traffic flowing. A bit further out, cities will build digital twins, exact virtual replicas of their road networks to simulate traffic changes instantly. And the far future? We're talking fully autonomous, citywide traffic management making all the decisions in real time.
Because ultimately, the goal of all this data fusion and predictive modeling is simple. We are shifting traffic management from reactive enforcement to proactive mobility optimization. This really isn't just about handing out more speeding tickets. It's about engineering safer, smarter, and much more sustainable cities where traffic flows naturally and we prevent accidents before a crash ever happens.
So, I want to leave you with a provocative question to chew on the next time you navigate your city. Does the incredible benefit of proactive AI-driven road safety truly outweigh the reality of 24/7 automated surveillance? It is a very delicate balance between maximum public safety and our personal privacy, and it's a conversation every smart city is going to have to navigate. Thanks for joining me for this explainer, and I'll catch you in the next one.